We are going to look at question paper 2018 February paper 1 question 5. It's all about the exponential graph and its inverse. So let's get to the question. The graph of g of x equal to a to the power x. So that's an exponential graph. It's drawn in the sketch below. And we are given the point S, which is 2 and 9. And then they told you that T is the y-intercept of G. So let's look at the questions. The first question, you have to write down the coordinates of T. Okay, so that is quite easy because 5.1, with T, we know that T is the y-intercept. So you make x equal to 0. So it's g of 0 equal to a to the power 0, which is equal to 1. Therefore, the coordinates of T will just be x is 0, y is 1. So this is 0 and 1. Then question number 5.2, you will have to calculate the value of a. Okay, so the value of a, the graph again, it can be written as y is equal to a to the power x. Then from there, we're going to substitute a point. So what point are we given? We are given 2 and 9. So x is 2, y is 9. So it's 9 is equal to a to the power 2. Then you take a square root, and then you get a is equal to 3. Meaning that your graph now is g of x is equal to 3 to the power x. Then the next question, the graph of g, and so the graph h is obtained by reflecting g in the y-axis. Write down the equation of h. So if you are reflecting in the y-axis, you will have to replace x with negative x, meaning that the graph of h of x, 5.3, the graph of h of x is going to be 3 to the power, and we are replacing this x with negative x. So it's 3 to the power negative x. Okay, then we are done. Then the last question, write down the values of x for which log base 3 of x is between 0 and 1. Now we know that log base 3 of x, that is the inverse of 3, y is equal to 3 to the power x. So what we're going to do here, we're just going to sketch that inverse, which this point 1 and 0 and 1 is going to be now 1, 0. And then that point 2 and positive 9, now it's going to be 9 and 2. And we know that this was the x-axis, was the horizontal asymptote for the graph of g. So for the graph of g minus 1, now your y-axis is going to be your vertical asymptote. So you're not allowed to touch the y-axis. So the graph will go like this. So if this is g, that one is going to be g inverse. Okay, now the question is, you have to work out the values of x for which the log graph, the graph that we have just done here, the inverse, is greater than 0 and less than 1. So one way of doing it is to draw a horizontal line at 0 and another horizontal line at 1. Then we're looking for the value of x such that the graph is in between those lines. So I'm going to draw those lines. So I'll start with a 0, which is basically the x-axis. And then 1, that will be the other line. Okay, let me fix it here. All right, so that is the line y equal to, this one is y equal to 1, this is y is equal to 0. Already we have the coordinate here. We need the coordinates for this point. So the coordinate there will be, we don't know x, but we know that y is 1. So we can solve for x by substituting y to be 1 into the log graph. So remember, the log graph is y is equal to log base 3x. So make y to be 1. So it's 1 is equal to log base 3x. Okay, so that's 5.4. And then from there, you're going to now change this log form into exponential form. So basically, you're given this form, you want to change it into that form. Right. So this one is saying you have to start with this y, right? And make this a base, and then that will be an exponent. So in the same way here, you're going to have x is equal to 3, and then that's power 1. So x is equal to 3. So we have our coordinate here, that is 3. So therefore, the solution here, x is element of what? We want the graph to be in between the two lines, that is greater than 0 less than 1. So the graph must be in between these two lines. And the values of x where the graph will be in between the two lines will be x from 1 up to 3. So it's element of 1, 2, 3. So in this case, it's going to be round bracket because it's just less than and it's just greater than, not less than or equal to or greater than or equal to. And that's the end of that question.